let's be understanding the context of building. And I think buildings and human beings are very closely related. As the numbers are increasing, so is the requirement of the building itself. And you have seen, the rate of construction and the kind of construction going up is very, very, I would say at a higher speed because of the growth and development of the human numbers plus their related requirement. And in India, if you are seeing a lot of construction, is for the simple reason we as nation are adding a lot of human beings. Number one. Number two, we are urbanizing. That is what. And thirdly, our family system is breaking, and the families are getting shorter and shorter and smaller because we were coming from joint family to unitary family. So in addition to population, with the migration, changing social structure and the physical structure, we are finding the development of buildings have been changing over a period of time. In fact, our requirement have also changed. So once you are increasing in number, you are urbanizing rapidly, and that is India has been urbanizing rapidly because in the last 100 years, we have gone 3 times. Urbanization level have gone 3 times, 10 to 31%. Urban number of cities have gone from 1975 to 37935. Total population multiplied by 100 from 25 crore to 121 crore. I'm referring to the census 2011 because census 2021 is not available. They are just to take it. But the population clock of UNO says India is already 134 crores, We'll see how it has been, ratified by the census which is there. But the main fact is, if the total rural population has increased 3.5 times, urban population has increased 15 times, that's 2.5 crores to 37.5 crores. So once you have more people, more, urban development, surely you need more buildings for your residence, for your healthcare, for your education, for your leisure, etc. And therefore, there are more and more buildings are coming up. And it's projected that India will be needing around 700 to 900 million square meter of built space annually only in the urban areas. But I think we have to understand, before I go back to the buildings, we have to understand the context of the building. So please understand, buildings are different. Buildings are distinct, buildings are universal, and building have lot of impact and implication for human being. And the day we came on this planet Earth, about, they say about 5 lakh years we came on this earth, but our first thing we did was to start searching for our shelter. So the kind of buildings have changed over a period of time with our requirement, with our technical know-how, with our knowledge of material, with our technology of construction, and our changing needs of living, working, and other kind of measure which we are required to take. So if at all you see our history, you are defining by the building itself. All the civilization which came on this earth, they were either Indus Valley civilization, Greek civilization, they are all being defined by building. And tomorrow, when we go back, when we go back in the history, next generation will come, they will all be looking at how we were living, and they will all be defined by the building. So building remain very critical, for human living, growth and development. But please understand, there are two only environments which exist on this planet Earth. One created by God and other created by you. God created the natural environment, we created the man-made environment. And they are all in contradiction, conflict, and antithesis to another. And all building are basically trying to compromise with our environment and ecology. But please understand, building remain relevant, building were relevant, building are going to be relevant for us, because if you cumulatively analyze your life, how you live, how you work, how you travel and what you do, if you calculate your life cycle timing, you will find 80% of your time is spent within the building. And when I'm talking to building, we are born in hospital, we are basically all family thing taken up in your homes. Education is in schools, and then healthcare is again in all kind of building itself. So everything is taking place in building. So building basically remain very, very critical. And you can think of, if 80% of our life is spent within the building, only 20% is outside, surely your building impact your quality of life. And Winston Churchill said, first we make the building and then building make us. So it will depend upon what quality of building there, so that if you make a better quality of building, surely you will have a better quality of life. And if you cumulatively see it, buildings are vital for humanity, community, society, cities, environment, ecology, resources. Your identity, privacy, security, safety, and quality of life is all dependent upon the building you live in. So don't think buildings are dead entities. Building a living organism. And if you analyze your system, if you have done ever a study, you'll find all sustainable building, all resource efficient building, or whatever they call green or eco-friendly building. If you are living in such a home, you will be happy and healthy. If you are in a sustainable hospital, I think the patient will be very quickly cured. And if you are sustainable school, learning will become easy and meaningful. So please try to do an experiment when you are in a college, you are teaching. If you can make your building and your environment green and lean, you'll find your teaching will be more meaningful and will be more productive, and students will be happy to be there for the reason it makes learning much quicker. Of course, the role of teacher remains. So therefore, we are looking at, we looked at the positivity, because building remain relevant to us. Building are living entities. Don't think buildings are just brick and mortar. No, the buildings are breathing all the time, because we are living in an environment generated by these kind of material and this kind of this total context. So therefore, I think the context shall be, we have to respect building. We have to value building. We have to understand the fabric, structure, and relevance of building in the human living. If we make better buildings, I think we are leading to a better world and better quality of context in life. They were relevant, they are going to be relevant, and they shall remain relevant. And when I said there are positivity, I think we should look at, because buildings are not simply positive. Buildings have their own negativity also, in their terms of their design, construction, maintenance, operation, etc. And if you look at the entire life cycle of the building, you can see how buildings are impacting this planet Earth and are in our environment and ecology. So building remains large consumer of energy. Please understand, Corbusier said, buildings are like machine. Building any machine operational, what you have to do is you have to feed it with all kind of resources, energy, water. They need all air conditioning, heating, ventilation. They are all required as part of making building a place to live, because you have to create an ambient temperature. You have to save from the natural elements of rain, snow, cyclone, or anything which happens, heat or cold. All this is sheltered within the building. So building, if you look at the implication, in terms of resources, in terms of environment and ecology, building consumes 1/6 of the fresh water withdrawal on this earth. So if at all because we are seeing a sustainable building consume less water. So please understand, your contribution as a structural engineer will be what? How you consume less water in the construction and operation of building. 25% of the one-fourth of the wood harvested goes into making a building. One third of the total material which is taken out of the earth and which is extracted in this universe, they are all going to making a building. 40% of the global energy is consumed by building. When I'm referring to these figures, they are, they are only trying to be indicative, but they convey you the sense, that when we are looking at what the implication of buildings are. And buildings, if you look at this, building, we are looking at the entire life cycle of building. We are not merely looking at the construction of building. We are looking at designing, we are looking at construction, operation, maintenance, and demolition. So building remain responsible for not only resources, but one third of the carbon emission. They are generating waste. They are responsible for half of the chlorofluorocarbon which you use for cooling. And whatever you see, one third people, the people who are flocking to hospital, one third of the people are there for the reason they are living in bad building. They are suffering from the phenomenon of sick building syndrome. What sick building syndrome is? Building make you sick, building make you healthy, provided if you are living in a bad building, badly designed building, without airlight and ventilation, and this all kind of problem, bacteria, you become sick, But if you have properly lighted, ventilated, and indoor air quality of the, where the carbon emissions are the lowest, you surely are in a better kind of those environment. So you will be happy and healthy. So we will find, that building, we look at when cumulatively we analyze the building, so from those two slides you can make out, buildings are full of dualities and contradiction. 70% of global warming can be attributed to buildings and transportation. Building remain larger consumer of energy, resources, generator of waste, and they are polluter of environment and ecology, and they are generating carbon footprints. If at all you are heading for a problem of global warming, one of the major component as a contributor remains the building itself. So buildings, I said, remains relevant for human living. They can make you sick and make you healthy. But please understand, I am again repeating, building and nature remain antithesis to one another. So that, all buildings is an act against nature. So there, I think we all role and responsibility shall be how to minimize those conflicts. What conflict I was referring to, that was here, that they are consuming lots of water, they are consuming wood, raw material, energy, and they are emission this. If you can minimize those kind of things, I think you have done your job. When you look at the energy consumption globally, a majority of energy is consumed by developed world. A Chinese consume 3.5 times more energy than us. American consume 11 times more energy, and as Indian, we are also consuming we have started consuming large energy. They say energy consumption is an indication of the prosperity, growth, and development of a nation. And the reason for this energy conservation shall be industrialization, urbanization, prosperity, and globalization. But I tell you, energy shall remain the motive force. Energy will be required. Energy will be essential. You cannot cut down the energy. Energy need will be rising. But problem will be what energy you use. So energy has a color. You have a black energy. You have a green energy, Black energy, any energy generated by thermal plants, You are burning coal. You're generating carbon dioxide. You're transporting coal all the time, So that means the coal which is burned in India, around 60% of the total energy is generated by thermal plants, You're burning coal away. Thousands of tons of coal is being burnt every minute, And when you burn coal, surely you are emitting carbon dioxide. But question remains, I'm not saying you stop or the world will stop using energy. No, I think our system approach will be what? Number one, whatever energy we consume, we will have two-pronged strategy. Number one, whatever energy we use will remain energy efficient. That means we will have those kind of systems, those kind of buildings, those kind of machinery, those kind of operation which minimize the energy consumption. And secondly, we will change the color of energy. We will not use the black energy, but we'll use the green energy. And green energy can be by what? You have sun, you have wind, you have seashore, you have a thermal energy, you have, biogas energy. So these are the energy which are available to you. Will like to ultimately shift to nature-based energy rather than, these fossil fuel-based energy. So therefore, I think when we looked at the total context of the energy consumption, we find buildings remain the largest consumer of energy. And please understand, if 40% of the total energy consumed by building, I think they offer the opportunity to be more, sustainable. So whenever you have a problem, please don't go out and don't look at the outside. Wherever there is a problem, solution lies there itself. If buildings are consumer of energy, building can be made as, they can be made more energy efficient. So building remain the focus. So therefore, I think building offer the best option, and how we can reduce the energy consumption by building. When I look cumulatively the context of the building, you can define the total life cycle of building into 7 stages. That's a siting, design, construction, operation, maintenance, renovation, deconstruction, and reconstruction. That's the 8th one. And during entire systems, energy building do what? They consume energy, water, material, and the natural resources. Ultimately, what they are doing, they are generating waste, polluting air, water, indoor air, they are creating heat land, and there are flooding, and there's a noise. Ultimately, what is the impact, They are harming human health. They are degrading environment, and there are a lot of resources. So you can think of this is a building, what they do, what they consume, what have their implication on the environment effect. So we look at, who are the major actor in the building itself, building construction, building designing, building operation and buildingness, so that we focus on that. And when I said, if the building, life cycle remain eightfold, so there are two major actors. It's the architects, structural engineer, of course. There are civil engineer and their service provider. So all they are very vital. Of course, there is a owner, there is a person who is using it. They are, of course, there, but surely for creation of the building, we are the people, who are actively involved. And when we look at the, entire context of building, I would draw your attention to the man Vitry Weiss. He was a Roman. He was an engineer. He is known as the father of architecture because he was the first man to write a treatise in architecture, identifying what the characteristic of a good building should be. And he gave the 3 characters, Firmitas, Utilitas, and Venestas. The Firmitas means building should be structurally stable. Look at this. This is the job of engineering. Utilitas, building to be used for occupant, owner, and community. This has come both architecture and engineering. And then building should be aesthetically pleasing, beautiful to look at. That is Venestas. So beauty, utility, and the structure. He defined there are 3 components of a good building. And all building should be designed with these 3 parameters in mind. That was, defined more than 2,500 years by this gentleman, Vitry Weiss, who is called the father of architecture. So when we look at, what architectural design, what architects do, architecture is related with the art and science of designing spaces. So job of architects is to see how the spaces are allocated, how the external building envelope is there, so that whatever function, operation of a building is done, or whatever the people who uses this, they have ambient kind of quality of life within that. That means building should be able to create an environment with which the users remain happy and healthy. And secondly, building must be built in a manner that it remains conducive to environment and ecology. It does not damage the environment. It sustains the environment. It makes value addition to the architect. So the main designing of the building, considering its function, environmental aspects, is done by the architect. But this concept on the paper, when it's be transformed into reality, who will do it? It's only the structural engineer and the civil engineer. Let me also design. I know you are more knowledgeable, you know the structural design, but nevertheless, for my education, I would also like to define what structural engineer is. This is defined differently and distinctly. This art and so structural design, as that was, architecture was art and science of defining spaces, considering the utility, considering the aesthetic, considering the environment, considering the function for which the building was designed. In case of structural engineering, it is the art and science of designing internal skeleton of the building to ensure that building remain structurally safe, strong against all man-made and natural disaster. So they are trying to focus on the Vitruvius formula of, building should be, formitas, That means building should be structurally stable. So sustainable structure, looks at, in fact, you will do, I know you are all doing structure of the building. You are all looking at this tank safety against man-made and natural, forces. But question remains is, are you looking at the durability? Are you looking at resources? Are you looking at the economy of the building? Because you have to make sure buildings consume energy, and the factor of safety will determine that whether these buildings are economical. Of course, they will become durable, but all structural design have to be between two limits. That means you achieve this desired level of safety, formitas to the building, but make sure the building remains most economical. So therefore, when you look at the definition of architecture and structural engineer, one is designing spaces. You are giving that life to that structure, so that it sustained all kind of disaster and it does not do anything. But they remain two distinct, but remain interrelated sciences. Both cannot exist without one another, and both has to be relevant to another, supportive of another, and in fact making value addition. It's not the architect has dictated, the structural engineer will do it. No, structural engineer job is to educate the architect. Here, your spans are wrong, your structural systems are wrong. You are, but the structure will not be sustainable, and he can tell that you modify your design based on the, which is the most viable kind of stuff. I have seen, if you ever study P.L. Narvi, who is known to be the master architect, he was an engineer by profession, and he showcased how as an engineer can add with the value and make the beautiful building. So that remains the, relevance of structural engineering and architecture. They are one, contemporary to each other, supportive of another, but surely they are not subservient to one another. Please understand, structural designing is not subservient to architecture. In fact, structural designing remains one of the partner, collaborator, and advisor to advise architect in order to make sure whatever building is designed, they are sustainable, more livable, they are economical, they're consuming of least amount of energy and resources, and surely they have the required level of safety for the people who are living then. So ultimately, when we cumulatively look at what is a sustainable building design, so this is a design which is, please understand, I'm again, maybe repeating, sustainable building design, there cannot be a universal building design. It will be all evolving, devolving. Structure can never be static. Structure is always evolving and devolving. And you have seen how structure have changed over a period of time because of technology, because of material, because of, the construction technology now you have in mind, and the methodology of construction. They have all redefined the building, the design, the structure, etc. So structure in the sustainable building design will not be a universal. So that means you can't have a prototype of this. You will have same principle guiding the designing, but they will be contextual in the area, in the climate, in the place where they are located, where their wind direction, landscaping. There are so many other factors, the material which are available, the technology which are being used. I think they have all been relevant, and that's what a sustainable building design be static, shall never be fixed. It will be constantly evolving with the fact, that it will not harm, it will not degrade the environment, but, make value addition to this. And here, the role of the structure will be that whatever structure will be done, it will take care of the environmental issue, it will take care of the resources. That means minimum resources will be used. It will not mitigate against the environment. And it is not that only during the construction, but whatever the life of the building is, during the entire life, whatever structural engineer has done, whatever the specification has been done, whatever the material has been used, whatever the technology has been, evolved, they shall all make sure that building remains, sustainable. So it's sustainable when you look at both the factor, what is sustainable building and structural design. So what it involves, what are the principles which are involved, what are the basic factor you will consider, what are the issue you will address, and what will be your approach while designing a building. So therefore, it will be number one, you will minimize the material use. So when you are looking at material, I'm not saying you are compromising with the, security, safety, and the utility of building. No, you are minimizing material use. So you are making building materially efficient. Number two, you are specifying recycling. That means you are not extracting material from the earth itself. So whatever material is available, whatever to the best of the extent, it is not that all the material which is available. So you will use recycled material also as one of the issue and one of the material. Then use substitute material. If there is a wood is not available, it is impacting this, you will look for the other material. Then you will make sure whatever material you use, it has minimum of energy which has gone into making of this. So when you talk about embodied energy and operation energy of the building, then it is a building which remain focused on environment and economy, and you are looking at improving the life cycle, performance of the building, and ultimately you are trying to make building lean and smart. That's what the context shall be. Ultimately, you will now look at the building which are lean, smart. They have less material because once they are lean and smart, they will have less material. They will have more efficient. The area under walls, etc., will be lesser, and you'll find the material which gone into making are drastically cut down. So I think I have to, looking at the entire context, you can see the relevance of architectural design and structural design. If we are aiming at sustainable buildings and design, I think structural engineer has to do its job. Even if architect, doing anything, stressing that he wants a building sustainable, if the structural engineer does not address that issue, I think building will never ever achieve the concept of sustainability. So they both remain relevant, they are meaningful, they are basically this by sustainable architectural design will combine creativity and technology, and I think both have to work together to make it a reality, a sustainable building through structural design. So we'll look at back, why we should, when we are, of course, sustainable buildings are relevant, but what is the need of sustainable building and what is the need of a structural, sustainable structural design? And we said, 40% of the global carbon emission can be attributed to, and 36% of the energy used globally is can be attributed to the way the buildings are being planned, designed, constructed, and operated. Structural engineer and practices, why they have, what the role they have in making a building sustainable, because we know buildings have impact on environment, ecology, and resources, and they are generated a lot of waste. So here comes, that when large number of buildings are constructed, so that means the implication of these all resources waste will be very, very high, and the impact on the climate will be very, very large. But let me tell you, the building typology have been changing very rapidly. Earlier, you see, they were low rise, now you are high rise. Earlier, the buildings are small span, now buildings are very, very large span. Earlier, the buildings were very small, now the buildings are very, very large. So the changing typology of building you can observe. All this has been possible. What, only three things has been make it possible. One is the steel, other is elevator which makes you move, and thirdly, of course, glass has come in which has helped in making these building a reality. So because of the changing typology of building, large number of construction which is being undertaken, impact of building on climate, and they are responsible for consumption of resources and also generator of waste. Surely, if we have to make this world more livable, the temperature degree when cannot be other but to design buildings are basically, of environment, you know, acting and a building, first and foremost thing you should understand, we're destroying, we're converting the natural environment into man-made environment. So number of wildlife habitats they get destroyed. Building during construction consume lot of energy. You are using heavy machinery. You are using, burning many things to produce things, You are using material, construction material, which are manufactured through processes, and it is not only when you are constructing a building, but building, I said, as a machine will continue to use energy in its entire life cycle during its operation, maintenance, etc. So if you count, this has implication, and the structural engineer has to address those kind of issues, etc. When we're looking at buildings, I think you have been very rightly said that building, if you look at how the changes, how the context has been changing. If at all somebody comes to you that please design or construct my building, he will say you three things he would always be demanding from you. Number one, he would say, please take minimum time to construct my building. Number two, the quality of building should be highest. Thirdly, please make sure, while you are taking minimum time and you are ensuring quality, very high quality, the cost should be less. So cost, quality, and time become the three parameters. They were relevant, they are relevant, they are going to be relevant. But mind it, they are part of the one triangle. If you are looking facing one, they are two opposite. If you are reducing the cost, you are compromising quality and you are increasing time. If you are cutting down the time, you are increasing the cost and the quality. But it was thought of cost, quality, and time are not the three parameter. This is, you have buildings have implication in terms of resources. We have counted it. It impacts biodiversity. We have seen it. It it is responsible for healthy environment. So building, in addition to cost, quality, and time, has implication in terms of resources, biodiversity, and environment. So in addressing these three issues, building have also to be issued three more these parameters. But now we look at building don't have in the local context, building have global context. Building are important for healthy economy. Building are relevant for global warming and they need to be addressed and planned design accordingly. So building are now looked differently, not merely in cost, quality, and time. This is what UN 17 goals say, and goal 11 clearly says that you have to make cities human settlement inclusive, safe, resilient, and sustainable. And they say, in this that you have to make buildings not only energy efficient, but also zero energy, and ultimately the aim is energy positive building. That is what the context. And therefore, if you have green buildings or sustainable building, you are out of 17 goals, you are able to address 9 goals itself. But when we look at this, let me first explain to you what green building context is, and we can see, how they are relevant with the structural engineer. A green building is one, who in its design, construction, and operation, what it does, Please understand there are three stages of building: design, construction, and operation. What a green building does, this is what Green Building Council definition of the green building. It reduces, it eliminates the negative impact and create positive impact on our environment, nature, and natural environment. So please understand all the operation of building, entire life cycle, designing, construction, and operation. Its job is what? It is taking away, it's eliminating all negative effect of which building does on our climate and environment, and it creates positive impact on, enhancing and making value addition to our preserving our climate and the natural environment. So this is this context, that you are looking at the climate, you are looking at the natural environment, and that's what our domain of designing and construction is. And what Green Building Council is saying, that through these green building itself, we'll be able to achieve those goals, sustainable development goals by 2050. That is limiting the temperature rise to 2 degrees Celsius, reducing carbon emission by 84 gigatons. You can think of the role and importance of this building, that we will make all buildings zero emission, and we will make sure that building and the construction sector cumulatively help in Paris achieving the objective of Paris Agreement, that is making this world sustainable itself. So green building has also been defined by another organization, and it defined it in terms of integrated process. It talks of a process, that the entire building, green building. Again, the focus of one is a relationship between built and natural environment. And what, that the process, the focus of project is, looking at what building you are creating and what is role and relation with the natural environment shall be number one. You are doing what you know. You are minimizing like a negative environmental effect. You are maximizing value. You are looking at the entire life cycle of building, design, construction, operation, and maintenance, and renovation and demolition. So all these, stages of building, they do what they will do this. Basically, they are environmental, they are only reducing the negativity caused by building, and they are promoting the positivity of building. And this is one definition which looks much simpler and much focus, that a green building must have five characteristics. It reduces, number one, it reduces less consumption of water. It reduces consumption of water. That means you are using less when you are doing building, you are doing constructing building, or when you are operating building. You are optimizing energy efficiency. So water, energy, you are conserving natural resources. That means you are minimizing use of natural resources. So you are generating less waste and providing higher, healthier space for occupants as compared to a conventional building. So your energy, water, resources, waste, and your, indoor happy air, the air which you breathe in within the building itself, that are the five parameters. And this is what which has been explained, that you are trying to conserve this, and the result is you are trying to reduce your energy. You can reduce up to 50%, carbon emission up to 39%, water 40%, and solid waste 70%. And once you're looking green building, you are trying to do what you are remaining design efficient, you are remaining structurally efficient, you are remaining energy efficient, you are water efficient, resource efficient, material efficient, and your design focus on environment, ecology, indoor air quality, and the users who are going to be using your building. So building will remain site focus and durability. Of course, it will all building will be structurally and operationally durable, and it will try to minimize the consumption of water, this land, energy, and water. So, in fact, if otherwise would like to say, rather than being a consumer, building should be a net contributor or producer of energy in this. And accordingly, when you are reducing consumption, you are saving water and you are saving energy, surely you are paying lesser bills. But in your cost of operation goes less, but in addition, you are contributing to the environment, because there are less temperature rise, less air conditioning needed, and you are making people who are living there happy and healthy. And once people are happy and healthy, surely they are contributing to the productivity. And this is what has been improved, that the cognitive score of, in America, it is proved the cognitive score of the people who are living in green building is around 102. They are 8% contributing more profit to the people. They have less attrition rate. That means people don't want to leave the green building where they are working, and they sleep 42 minutes more than the normal building. So they are the benefits, but please let me quantify it. If you are having 1 million square feet of built space, in green, you will be saving carbon footprints 8,000 to 12,000 tons annually. And the electric load, once your electricity load goes down, that means 3 megawatt of connected load will go down for every million square meter. So energy saved is energy produced, you all know, whatever you save, that means whatever you reduce, that means this you have cut down the total consumption, you have conserved those resources, you have made it possible for to be utilized in the longer period of time. So what you are doing, you are reducing 70% of waste. That means all these area land needed, all these hillocks of those the garbage which is created, plus the number of vehicles and the manpower involved shall always be less. If you consume less water, that means you have less size of the network of the pipes for supplying of water, and accordingly water generated at waste, which is 80%, will be less. So that means you will have a reduced sewerage pipes, and accordingly your STP will also be requiring less capacity to deal with. So it's a win-win situation, both for government, for people, for the owner of the buildings. And this helps financial benefit, environmental benefit, and social benefit. Please, somebody's mic is on. So I request you. So after we have done this, let me, after architecture, hello. I will now define sustainable structural engineering. So, once we are talking of the sustainable architectural design, so what sustainable structural design is helping architects? In fact, the broad objective of buildings are being achieved by structure, because you are minimizing environmental pollution. You are making structure which is supportive of environment. You are conserving environment before, during, and after the building is constructed. You are making sure building design and structure remain energy efficient. They have lesser embodied energy. They require less operation and maintenance energy. And then, you are using recycled renewable material. You are improving the durability of structural system, and you are reducing the on-site waste of this. So if we say green building require less operating costs and less cost effective, the study done in USA has said the structure. Look at the role and responsibility of the structural engineer and the construction engineer. They say that if you have sustainable structure and use these technology which helps in promoting structures, sustainable structure construction, you could save $400 billion in global spending on energy specification itself. So that is the saving. Architect will do its job that he's trying to make it building more efficient, but actually it is your role, your responsibility. When you construct the building, you evolve the design of the building, you evolve structural design, you do the specification. You are the man who can save not only resources, not only energy, but also in financial term, 400 billion, that is the amount of money you can be spent by in terms of when you do the sustainable structure construction, etc. So, this sustainable structure engineering solution helps you what you know. They help you in improving the life cycle in performance. You are specifying materials which are recycled. You are using material which is not raw and fresh, but you are using substitute materials. So when you are doing the sustainable structure design, what you will keep in mind? Number one, during design, construction, and maintenance, you will look at the environment, social, economic, and aesthetic aspect of structure. You will know what for this building is being constructed, whether education, residential, commercial, institutional. Then what are the raw material which are being used by it. So your design will be what you know. You are looking at those technical issues of environment, social, economic aspect. You will look at the function. You will design with minimum of material. You will use material which have low energy in production, which are durable, which are locally available, which are from recycle, and which are used in the natural form. And then you are trying to minimize the use of steel and concrete because they are large consumer of energy, and you are trying to have substitute. But no, that this is, so you have steel and concrete. Maybe tomorrow you are having a substitute for steel, which is low energy. You will have a pattern of concrete, which is low energy composite, and that's what the innovation, that's what research and development shall be, to make the structure more sustainable. And then you please understand, you are focusing on sustainability for all aspects, whether it's the beam, truss, column, arches. That's how you can make it thin and smart. And then you are looking at structural flexibility. One thing, as a structural engineer and what architect we do is, we design the spaces, we divide the spaces, we design the construction and finish it off. But building is not for a day, building is not for a year, building for 40, 50, 60 years, and you see the role and construction of building will change, the space requirement will change. Ultimately, I would suggest, while you are doing a structure, while an architect doing the design of building, there must be inbuilt structure, a flexibility in building, so that the building can be modified. If you want to have largest space, open space, it should be available. If you want to divide it, you can do it without in manipulating with the structure. And then your design shall be what, you are reducing the self load of building, because there are two load, self load and the live load. So if you make the building less in self load, that means you are saving on the structure of the building. And you might like to make your building lean and smart, that means your wall will be thinner, your all structure beams will be thinner, you will have more space, for utility within the same built area itself, and that will help you in making building and the structure sustainable. So I think when you are looking at the green building, when you are looking at sustainable structure, and when you are looking at the entire context of building, don't look at the initial cost, look at the life cycle cost, because building is going to be there for many of years. So in fact, you are not having cost-effective building, you are having basically cost-effective living. So that building contribute to the lesser cost on your this water, this waste, and your energy, and provide you happy and healthy this. So please, whenever you do a project, don't look at only initial cost. Look at the life cycle cost, because initial cost is what, which cost is going on making of a building itself, and life cycle cost is what, the initial cost plus operation and maintenance cost. And you will find there is, this is a short term vision of it. The initial cost is short term, looking at the cost of building, and when you are looking at life cycle cost, you are looking at the long term cost of the building. So please understand that building have to be more cost effective. Not only initial, maybe initially you can afford to spend more, 2 to 3% more, if it contributes to the lowering the life cycle cost of building. So this is what let me also come to this. This is the component of the life cycle cost of building. Only 10% of the cost goes into making of building, whereas 90% cost goes into the operation and maintenance of building. So therefore, even if 10 to 15% initial cost goes by 5%, you are going to recover, because you are addressing 85% of the rest of cost. So please make your building cost effective on the life cycle. And look at this. The first building, which was green building, which was constructed, it costed 18% more. It was this IGBC headquarter in Hyderabad. This was 20,000 square feet constructed in 2003. It costed 18%, where you spent 10 lakh of rupees, it costed 18 lakhs of rupees. But nevertheless, it was the only first building, because at that time there was no concept known of green building and green structural design itself. So building, despite being, first platinum rated building constructed outside the America. So this led to 18% higher cost, but this cost has been recovered 7%. And over a period of time, I'm talking to Switzerland One Earth, which has 8 lakh square feet of built space, which have platinum rated. It costed 2% more, and they recover the excess cost which was recovered, the spent was recovered in 2 years, and rest of the time building was saving. So yeah, over a period of time, if you find the cost of constructing green building has been going lower, but provided your design involves all kind of these feature itself. So green building, when you look at the design of green building, which is a domain of engineer, architects, it is looked at, it is based on climate, orientation, sun movement, wind direction, and then space, placing a space, the building envelope, the material and technology, and indoor air quality, they cumulatively make a green building. And look at this, there are all components which are addressing the issue of architects and the specialization of an engineer to make this, because you are the one, he prepares the planning and designing of building, but ultimately it's the material, technology, and all kind of things. Indoor quality will depend upon how the building is constructed and made operated. And let me also explain to you, a green building is nothing building with nature, It's nothing using nature and natural elements. It's a Prithvi, Jal, Agni, Vayu, and Akash. These are 5 elements which goes into making a building. When you look at the energy component, please look at this. If the total energy consumed in the construction of building is divided into 2 parts, One is the embodied energy, that means the energy which goes into making of a building, and then operation and the maintenance of building. So 10% energy goes into maintenance, and rest for 74% is the operation in this. So you can look at that 16% of the energy is the embodied energy. So please, how you can reduce the embodied energy? You are using those material which have lesser energy used in the construction of build. So all natural material will have lesser thing. All the things which are processed, they made in a factory, they will higher embodied energy. So therefore, I think we will see, how energy can be minimized. So ultimately, we will make sure the building have lesser energy. That means, I will explain to you how this, because embodied energy, if you are using material from outside, you are extracting material, processing, you are transporting, and then you are installing those material itself, Then operation energy is the energy which during the occupation, you have heating, lighting, air conditioning, ventilation, all this kind of energy which is being used. Maintenance, of course, when you change, you have addition and alteration, that also consumes energy. So a high performance building, what they will do, they will not only reduce the embodied energy, but they will also look at the how to reduce the operation energy. And energy, building gains heat, building loses heat, and it is because of the air leakage from your doors and windows, etc. Then you specify high performance window. There are buildings, you have those conduction, convention, and radiation. This is how the building or a heat is lost and gained by building. And the buildings, the building envelope, the walls and the roof and the windows, they are the major culprit, where the building or heat is lost. So you have to make sure that they are properly taken care of while this energy is there. So what we are trying to say? We are trying to make sure, number one, that we are not using the black energy. Secondly, we are making sure that buildings use their own production of the energy so that they remain relevant and they are meeting their own things. when you have to design a energy efficient building, first thing is your design must be led by a passive approach. That means you are reducing. If your design goes wrong, that means if you are designing not with nature, sun, etc., then I think we will never be able to do justice with these sustainable building. So you have to make building which are climate responsible, and your design shall be looking at making best use of daylighting. Sun brings two things, light and heat. So therefore, wherever you need both, bring them in. If you need daylighting, you don't need the heat, you have to cut off the heat itself. So you have to integrate your building with the nature, and in nature there are two things. One is the sun, other is the air. So therefore, make best use of this. Secondly, when you are this first thing, why so you have it doesn't cost anything because you are doing a design and architect is being paid for that, and has to do that job. Secondly, but you have a lot of things being used. You have computer, you have lighting, you have cooling is set, and everywhere you are using machinery. Please make sure our light fans and air conditioners, they are rated, they are efficient, and they're star rated, so that you get you consume, they can consume minimum of energy. And thirdly, whatever energy is being used by building, that is being compensated by this photovoltaic cell, and that remains, of course, costly because you're generating electricity. So this is, you are having high performance window, and look at this Bahrain, this trade center, where they have been able to, what structural engineer advised the architect, instead of one building, you should have two towers. And the two towers, they are 240-meter twin scrapper tie towers, but they are joined with bridges. And in that bridges, what they have done is they have put, those dynamo, they are rotors. So there are windmills there. So they are all, because they are crossing across the wind direction. So they are moving all the time, and they are generating, and they are able to generate all 24/7. They are generating electricity, and they are meeting 15% of this. This is the, another building which is done by Apple, and this is called Cupertino. So this is the headquarter of this Apple, the watches you wear and the mobile you use, and this remains one of the most energy efficient. They have 17 megawatt of the solar panels on the roof itself, which meets 75% of the energy. And in addition, they are using biofuel energy, which is generated, which meets the rest of the needs of this. So this building remains zero energy. It doesn't need any black energy itself. What they have done is they have 360 acres of total land. They want a ship building to be, designed as a ship, and that building covers only 64 acres. It is 3-story down, 4-story up, and they have put 80% of the site is now green, planted with trees which are local, which are indigenous. Of course, they have done a lot of things, innovation, and this remains one of the unique building. So when you have a green building, you will be able to address the air conditioning system whenever you need it. That a 1 ton of normally a 1 ton will do cooling of 150 square feet. In case of green building, it will be 600 square feet, and it has been recently said that Microsoft has been able to cover 900 square feet of cooling by only 1 ton. This is the level of energy saving you do it. And how you do it in the design itself, I'm just explaining to you that you have these light coming in, but you have light on the southern side. Naturally, the heat will come in. Instead of clear glass, they have put the glass embedded with photovoltaic cell. So these photovoltaic cells, when the sunlight puts in, there are small puncture which allows the light to go on, but the heat is absorbed by this. So they are generating electricity. So you can use the glass facade is not only for your bringing light, but also you can generate electricity. And if you can do on the western side, that will be great. So I think there are now the photovoltaic cell. Earlier, you see the photovoltaic cell, which are on the facade, which are giving the generating electricity. But now there are bipolar. That means bifacial. Your upper face will also be generating electricity and below also, because whatever sunlight fall directly, that will be converted to electricity, and whatever is reflected from the ground, that will be done by the lower side. So you can have 20 to 30% more efficiency of this. So that was the context of this building, to how you can design, you can structure it to reduce energy consumption, and then change the color of the energy from black to green itself. Now come to water. Water remains very, very important, and you all know lot of water goes into making of a building. But please, I will request you have all know recycle, reduce, and reuse, but you can also do refuse. Fourth one, so that you have minimum water. And water shall be consumed. Water is needed. Water is the elixir of life. But water should not be treated as a commodity for sale or purchase. It's a commodity which is gift of nature, which need to be preserved. And India has only 4% of the water, but we have 17.7% of population, and we have largest animal population of the world. So India is already facing a challenge of water. I think we need to value water. Number one, what we'll do is we will minimize the consumption of water. Number two, we will see, whatever rain water that is harvested itself. So ultimately, what is the option for you? If you are reducing, making a building water efficient, please see how you can minimize the use of water during construction. Please, sometimes somebody do a research that how much water is consumed during construction of a building and how you can minimize the water. I think that will be a great contribution to make the building more sustainable and more, water efficient. Then you have to use strategies. That means you have to slow the flow. And only thing is, if you want to reduce water consumption, you have to break the water. How you break the water? You mix air into that. So you don't use water once, have multiple use of water. Then you can use dual plumbing system. You can recirculate the water. You need, of course, you meter the water, because we are all consuming ruthlessly the water. But of course, we have to make sure that even buildings don't consume water. Whatever WC you are putting in, what they do, the normal WC will have a cistern of 13 liter, but now we have 3 and 6 liter. We are reducing less. You have waterless urinal. That's what you can do to that. And you have landscaping done in a manner that you don't have grass. You have local trees which consume less water because they are made for that area. So therefore, don't go in for the trees which are imported from outside, which have no relevance, and green spaces consume a lot of water. So you have to make sure that your landscaping also does not consume water. Material, of course, material remains very, very important, and that's where you are. Basically, we are all concerned, and the challenge shall be that majority of waste in the cities which is generated is being done by what? Demolition of building. So this waste never get absorbed. It stays at, because it cannot be, it is not a organic waste. So the challenge is water waste management. So we don't know, we don't segregate the waste. We're straight with transporting and filling it either low-lying area, or we are dumping it somewhere. So I think construction and development waste remains very, very critical. And what are the material which you should use? Number one, material which are obtained from nature, which are renewable, which are harnessed and harvested in a sustainable manner, which are locally available because you are not transporting it material at nearby site, and which have lower, the which have longer life and which require minimum of maintenance and upkeep. And wherever it's a machine-made material, you can use that, for material which uses less of the energy in making it. And please try to reuse and recycle this. So this is your order. I would suggest, to all the students, the teachers of engineering and architecture, number one, please, retrofitting should be introduced as a, because buildings are being constructed, buildings are being demolished, they are being reconstructed. The student, whenever we are given job, this building is to be done. First, there is that building existing. We say first demolish that building. We destroy the building. But I think now we have to look back as professional, as people involved with this. We have to make sure, and if whenever the task is given, the building is existing, you should be able to do a diagnostic analysis of that building, how building can be reused, without much destruction and damage. So deconstruction should be included as separate a subject of study. I think if you do this, engineering will be much, much, well, I would say much useful, and will be making a great contribution in having those sustainable building design. So first will be, you will use, if there is building available, see how best you can use it to do it. Secondly, if it can't be used, best what are the material which can be solved. Then thirdly, material which has been destroyed, how you can be recycled. Then fourthly, you will use recycled material, local material which is available at that place. And fifthly, you will use the material which are natural material, which are easy material. So segregation, construction, and demolition, waste at resource shall remain vital for you. And we will do this is embodied energy. You are extracting material, you are transporting, you are manufacturing, and then again retransporting back. So please understand, the material which are manufactured in factory, they are used to a minimum extent. That's what we say. You use locally available material. That doesn't mean you use local. You have research and development, that how you can improve the local material, how you can make value addition, how you can make more stronger, how you can have the different products which can to making the building better place. And secondly, you do research in the existing construction technology which are used locally to make your structure more relevant than this. So ultimately, like fly ash brick is one, this is one which reduces embodied energy, environment friendly. It has highest degree of thermal insulation. It is fire resistant. It doesn't cause fluorophylline. Then you have aerated cement concrete. They are non lightweight. They save labor. They are reduces the self load. They are acoustic in nature. They are basically does not allow the heat and lost and this gained, and they are sustainable in seismic activity. Then they are finished. They don't require any other finishes, etc. Then they can be used in natural state. The UPVC window are the other one. Of course, they are expensive, but they are user friendly, eco friendly. They have longer life. They have minimum, the requirement for maintenance and upkeep. And bamboo remains the, steel of 21st century. Bamboo has lot of hope because bamboo have lot of inherent advantages, but bamboo have to be used with care and caution after treatment itself. But bamboos are the one which ultimately capacity at a very far, it's a natural grass, they call it, naturally available, everywhere it can be grown, and it's durable, cost effective, lightweight, and this has strength of both compressive and tensile strength, and it contributes to employment, and also sucking of carbon dioxide and improve the indoor air quality. Then indoor air quality remains very, very important because we are living in an environment, and that will be what that will depend upon what material use. In addition to daylighting, ventilation, and looking at exterior, the most important thing, which in fact it's the indoor air quality which makes you happy and healthy. So indoor air quality will be dependent upon what material you are using and what finishes you are using. So please make sure you don't use the material, you don't use the those finishes which are chemical based. Otherwise, what will happen? That all chemical will be dissolved on this air, and that we will be all inhaling. So you have, when you are improving the indoor air quality, you have to have a good ventilation system. You have to choose construction material which have low VOC. You have to have sustainable building material like wood, recycled glass, renewable material like rubber and bamboo. You have to choose finished product which have zero or low VOC. Use indoor plant. You have to eliminate dampness. Never ever use carpeting, and you have to eliminate smoking, and you have to have sensor within the room itself which are publicly used to assess what is the air quality inside. So I think air quality, these are the three plants you can use it. One is Erica plant, snake planting, and money plant. They are available. They are like Shiva. You place in your room, you'll find, they will be all taking away your carbon dioxide and will be releasing oxygen, which are required for all of us. Please understand the building typology are changing. Buildings are going to be and distinct in years to come. You will have to deal with building with larger span, with larger footprints, and with high-rise building. But high-rise building have their own context, because they occupy less space. They have, they of course they can, they provide more and more space within the less coverage of the land. So there can be more interaction. Of course, there are positivity and negativity, but they have their own advantages because they consume less area, and you can leave large area, green area along that, and you can minimize the transportation need of moving people to this called future cities. This is 2 Mai High Tower, 500-story, and can you imagine? 1 million people can be housed in here. 10 lakh log can be accommodated in this building. The design of this building is ready. Structural design is already ready. It's a great building. I think you will study it, and this is going to be the future where you have lesser space. Maybe city like Singapore, maybe city like Bombay itself, which are coastal area and coastal city, they resort to this kind of building. But I think in addition to looking at designing a building, you will also look at the material which help in create sustainable design itself. This is number one, how you design. So this was a building, 71-story building, and please don't think the high-rise building are energy consumer building. This is zero building. How the gentleman has done it, this is 71-story high building. He divided the building in 3 components. In between, he left the space. And earlier example I told you, he has put those wind turbine. So these wind turbine are already, generating electricity. So they have used solar panel, they have used photovoltaic cell, they are using wind turbine, they are doing daylight harvesting, they have double skin curtain wall, and they are. So this building remain zero energy. That means whatever energy, this is all air conditioned building. Whatever is consumed, it is producing. So this is by done. Second is retrofitting, what I was talking to you. So please, when you do retrofitting, you are not allowing a building to be destroyed and demolition. You are only making structural changes. Think, how much you have done your contribution by retrofitting and being, but you are only strengthening the structural system. You are only removing the area which are derelict. You are reinforcing it, but you are not damaging, destroying the fabric of structure, which It means you are destroying all your material, etc. So this retrofitting, I said, and deconstruction and retrofitting, those please include two subjects of study in all engineering education and civil engineering, so that people understand the value of this and also know they learn the technique, etc. And they must be taken to places where the building is to be demolished, and you can give them exercise how this industrial building can be made into an office building, how it can be converted into a shopping mall itself. And there are example, people are doing like that. And people are, you can see the railway container are being used as, passes by, like bridges. They are used by houses, etc. This is this. You can, then comes the, your technology comes prefabrication. I think the construction has method of construction. You have to review on site, you have to take it off site. From, yeah, we need to graduate from construction to manufacturing, because everything cannot be done on site. The amount of things which are required globally, everybody is doing now modular construction. That is prefabrication. So prefabrication helps you in saving time, saving cost, saving material, saving water, saving theft, saving, all things which are needed at this. Of course, it has limitation, but it's a more advantages. This building, which was done, first building as this prefabrication building, it was done in Crystal Palace in London. It was designed in 2 weeks, constructed in 4 months. After this exhibition was over, this was dismantled and taken somewhere else. Then, brick remains very, very important. So please use brick in the natural form. Don't paint it in a plaster. Once you plaster it, you will paint it. So you can use it very innovatively. So this material has much longer life. It's available. It's very useful. Then you can use this, fly ash brick we talked about, but using brick as a rat trap masonry, which have cavities, it reduces 30% of the material which you use in making of a building. And then you have air cavities, it insulates that. So this is one, your technology which you can use it. So this rat trap technology, you can see to it, it can be applied, and this has proved it is worth, in making building structural design more sustainable. Of course, hollow bricks remains another option which can reduce the weight of this, reduce the material which goes into making of this, and then have their own quality. Arches, replacing the lintel, they remain very, very important. They are very efficient. Of course, they save you energy. They are basically replacing all your steel and concrete, because they can be done without any steel. There are so many arches. Then filler slab is kind of another technology which you can use it, because you are using bricks where the concrete is there. So your lesser steel is required. You have 25 to 30% cost reduction, and you can reduce the weight of the roof, and also make it more cost effective. Hollow blocks, they are 8 inches by 16 inches, or this is, you are reducing the width of the wall, which is, in case of brick, it's 9 inches minimum. Then you plaster it, do all this, it goes up to 10 inches. So you have thinner wall, you have more floor space, you have cavities, 25% of the total area, and then imagine one block is equivalent to 10 bricks, and one brick weighs 3.2 kg. 32 kg, and this is hardly 22 kg. So you are having less dead load. So they can withstand much. Then you are requiring less material for displacement and finishes, etc. So therefore, I think this could be another option for you to use. Now people are using what? They are using bottle bricks. The bottles, steel, this all plastic, we have bottles. You have now, where do you, dispose of? So you fill this earth, and then that brick that will use with this, and you'll find you are not, they will never be, degraded, and they will stay as such. So you are doing what? You are trying to use this plastic for construction of all, and of course that makes your buildings energy efficient, also material efficient, and you are using the water. So you can use experimentation. And just look at the bamboo, this Indian pavilion in 2000, 10. This was in China. This is totally made of bamboo. So that shows the versatility of bamboos. So you can have this kind of construction. This is machine, technology, which of laying bricks, which lays 20 times faster than a human being. So this is an option. Drone are being used to make buildings construction more sustainable and eco-friendly, and for monitoring. 3D technology is coming again to you, which is more resource efficient, time efficient, and cost efficient. And of course, you have all knowledge of your BIM, Building Information and Management Technology, which are available to you for monitoring this. Look at this, in addition to your technology, your intelligence will be very, very important. This is a tree which fell on a road. Otherwise, what we would have done? We would have started cutting the tree, and then transporting and taking it. What only they did, they removed the portion which was part of the road. So they allowed the road and let that become a bridge itself. And that's where your expertise, your knowledge, your understanding, your commitment will come in. And I think you can do a lot to make building more sustainable. But I would suggest you, this is a book, a manual of cost cutting for strong, acceptable housing. This is done by Laurie Baker, this gentleman who was an American, a British architect who came in India, worked in Kerala, and he's known as the father of mud architecture. And that's what he tells you, how beautiful building you can create with brick, and brick that can be made locally, and that using only mud, and it works for the poor people. And that book is available. If you want, I can share with you so you can think of this. But I conclude, I know, I'm sorry, I maybe have gone astray or this, but all the time I'm stressing green building has no replacement. There cannot be any option to have a green building, but green building cannot be possible without a sustainable structural design that has the total, I would say, bones, nerves, which make a building stand. So please understand, we are not yet finished. As per UNO, still by 2030, the 60% of still more buildings to come in. That means 900 billion square feet of area is yet to be built in. So it's not yet finished. We can do two parts, retrofitting, but please make sure all new building you design that remains sustainable, energy efficient and water efficient, and that should be made part of your life, part of your teaching and learning, part of your practice, professional practice, part of education, and surely we can help do it. And I can conclude, a sustainable building and a sustainable structure makes you happy, healthy, and more productive. It provides highest quality of indoor environment. It optimizes resources, carbon footprints, make building operations simple, technology driven, cost effective, and energy efficient. And don't think it's a slogan. It makes a business sense. It creates a win-win situation for both owners, tenant, occupant, community, place, and environment. And you're doing a great justice. Thank you. Thank you very much. I hope I've been able to convey the context of green building for you. Thank you, gentlemen.